ny. Okay. How much is the area? So remember, this length was 40, this thickness is 10. So now the new length L prime is 40 over cos 30 degrees. Sorry, sine 30 degrees. 40 over sine 30 degrees. Right? So you will see that area is 400 over sine 30 degrees. Now, what is the normal stress? Sigma NN. You see the notation? Normal. Force along the n direction. Phase is along the n direction. That way. Force is along that. Can you see that will be F times cos 60 degrees divided by A, which is F NX divided by 400 over sine 30 degrees. Which turns out to be F NX over 400 times sine 30 is the same as cos 60 degrees. Cos 60 degrees, which is NX again. That is F over A is sigma XX, that's F over A times NX squared. And in fact, this is what the book reports. This is sigma XX cos squared theta. Cos squared 60 degrees, which is the angle that the normal makes with the horizontal direction. Make sense to you? Which is 5 cos squared 60 degrees. Cos 60 degrees is a half, so this is 5 over 4. But that's not the only thing that's there. There is also sigma nt. That means t is this direction. That will turn out to be F ny over area, which is 2000 times sine 60 degrees divided by 400 over sine 30 degrees, which is 5 times cos 60 sine 60, which is 5 times nx ny. How did I get cos 60? That's the same as sine 30. Okay, so remember, I'm going to write this in a nice way. So sigma equals sigma xx nx squared, tau equals sigma xx nx ny. So the way you do that, so procedure is the following. Step 1, find sigma xx, that is f over a, that's easy to do. Step 2, for the phase in question, find nx and ny. These are the directions of the normal. Remember 221, we did all this unit vector in particular direction. That's what it is. This is where you really need this, okay? So at that time you are saying, when will I ever use this? Here is when you will ever use this. So this is actually directly from 221. That's why I'm not wasting too much time. Then step 3, the normal stress equal to sigma xx nx squared, shear stress equal to sigma xx nx ny. That's what you have to do. Okay. Example problem. So here is four kilonewtons. And this dimension is 25 mm or 20 mm. That dimension is another 20 mm. Then I have a little rectangle here that's oriented like that. Okay, and some angle is given. So let us say this angle is 60 degrees. That's what is given to you. Okay, so you have to find the normal and shear stress on each face. So we are going to do this. I will do it in Excel so you can see how this thing works, because I'm going to do the whole thing, all the numerical calculations and everything. So in order for you to see this better, I'm going to expand it a little bit. There you go. So first thing to do is to find, so I got F, and that is 4000 newtons. A is 20 by 20 equal to 20 times 20 millimeters squared. So sigma equals F divided by A. Can you see the two things? 10 Newton megapascals. So now we come to the question of angles and things like that. So let us get here, and I am going to show you. Let us look at this face first. I'm going to change the color here. I'm looking at this face. Its nose is this way, and so it makes an angle of 60 degrees.